Probability line is just like a number line that goes from 0 to 1. A probability of 0 means that the event is impossible to happen, and a probability of 1 means that the event is certain to happen, and the probability of 1/2 means that there is an even chance that the event will happen or not. The probability less than 1/2 means that event is unlikely to happen, and the probability greater than 1/2 means that event is more likely to happen. We can also use percentage to represent the probability line. 0 is simply 0%, 1/2 is 50%, and 1 is 100%.
Mateos, do you think it will be windy or rainy today?
If I look at my RMI mobile app, I can find out. It's forecasted to be nice and dry, a beautiful day.
Is that reliable?
Yeah, of course. Let me explain. To make a weather forecast, we first need observations. Observations from the ground thanks to the weather station and radars, but also from the sky through the use of weather balloons. And from space with the satellites. This is what we call remote sensing.
What do they observe with all this?
They measure the temperature, amount of rain, humidity, wind, atmospheric pressure, and the cloud cover. This data is processed to give input to numerical weather models that forecast the evolution of atmospheric conditions. Those models have to be as precise as possible. The more observations we have, the better our forecast will be.
There are 20 marbles placed inside a jar. 11 of it are blue, 4 red, and 5 are yellow. What is the probability that a red marble will be picked? So again, let's use this formula to find the probability. There are 4 marbles, so this means that the number of ways it can happen is equal to 4. And since there are a total of 20 marbles in the jar, so that means that the total number of outcome is 20. 4 divided by 20 is equal to 4 over 20, or 1/5, or 20%. So, it's right here, in the probability line. That means it is unlikely, and that makes sense since it would be less likely to pull a red marble than the other marble.
How do you know how likely something is to kill you? In the 1970s, Stanford professor Ronald Howard came up with the micromort as a rather neat way of putting a number on the chances of dying while engaged in some activity like skydiving, or driving down the street, or eating a peanut butter and jelly sandwich. 1 micromort represents a 1 in a million chance of you keeling over while doing what you're doing. The more micromorts, the greater the likelihood of you not being around too long. Micromorts are great if you're worried about your short-term chances of dying.
An employee at an electronics store earns both salary and commission as a sales rep. The table lists her estimates of the probability of earning various commissions next month. What is the probability that she will earn no more than $1,999 in commissions next month? Notice that the 1,999 breaks right there, and you want to say no more than, so that means less than or equal to that number. So all you're really interested in are the probabilities that are circled. So the probability that she earns no more than $1,999 next month is just the sum of those 5 numbers, which comes out to be 0.58.
What is the probability that I have the same pin as somebody else? So to start with, we're going to keep things really simple and just allow any possible pin number. So we have 4 places in our pin number. A pin is 4 digits. And for each of those places, you have a choice of 10. You can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. It's a lovely pin pad that I've drawn here. So slot number 1, we have a choice of 10 digits. So that's 1 in 10. So 1 in 10 chance for the first digit to be the same. Then we go to our second digit. Again, we're allowing all possible combinations. We can pick, we have another 10 choices. So there's a 1 in 10 chance again, picking the same second digit. Same for the third, same for the fourth. And to get the probability, you just multiply these together. It gives 1 in 10,000, allowing all possible pins. The chance that any random person, the same one as me, is 1 in 10,000.
In the case of rolling a dice, there are 6 possibilities. So 1 divided by 6 is 1 over 6, which is equivalent to 16.7%. So this means that it is unlikely to get a certain number of instances, but it is just as likely as rolling any number. In the case of tossing a coin, since there are 2 possibilities, then we have to divide the probability by 2. So 1 divided by 2 is 1/2 or 50%. Therefore, there is an even chance that the event will happen. For example, you have a random number wheel that has a number from 1 to 10. What is the probability of getting an odd number? So let's use the formula in getting the probability of an event, which is the number of ways it can happen divided by the total number of outcomes. There are 5 odd numbers in the wheel, which are the numbers 1, 3, 5, 7, 9. Therefore, the number of ways it can happen is equal to 5. And there are 10 numbers in the wheel, so the total number of outcome is 10. So 5 divided by 10 is 5 over 10, or 1/2. Therefore, the probability of getting an odd number is 1/2 or 50%. So it's right here at the probability line. That means there is an even chance an event will happen.